Ever wonder what a simple conveyor belt and, say, a super complex robotic arm have in common? Well, today, we're going to explore the universal language they both speak, a language of moments, decisions, and data. And trust me, once you get it, you'll start seeing it everywhere.
This might sound like a simple question, right? But it's actually the central puzzle that all industrial automation has to solve. See, it's not enough for a machine to know a switch is on. It needs to react to the exact moment it was flipped. You see, for a machine, the world isn't just about static states like on or off. It's all about the change between them. The machine has to be able to pinpoint the exact instant a signal shows up or disappears. And in the world of programming, we have a name for that precise moment: an edge.
And that leads us right into our first big concept: edge detection. Think of this as the very first tool in our universal automation toolkit. It's how a machine kind of freezes a moment in time, whether that's a signal arriving, which we call a rising edge, or a signal leaving, which is a falling edge.
Now, the brains of these systems, these PLCs, they use special instructions to act on these moments. For instance, in Allen Bradley's software, you've got the one-shot rising, or OSR, and the one-shot falling, OSF. The key thing to remember is this: the OSR triggers an action the instant you press a button, while the OSF triggers when you let go. Pretty cool, right? Okay, so we can sense a specific moment in time. Awesome. But now what? How does the machine actually make a decision based on what it sees? How does it know if a temperature is too high or if a tank is full?
Well, the machine does this using what we call comparators. And really, you can just think of a comparator as the machine's way of asking a question. It's the digital version of asking, hey, is this value high enough? Or are these two numbers the same yet?
And this is where things get really powerful. These logical questions, they're universal. The software might look totally different, but the core logic, is it equal to, not equal to, greater than, it's exactly the same, whether you're using Siemens, Mitsubishi, or Rockwell.
I mean, check out this quote from a Mitsubishi tutorial. It just nails it. It perfectly captures a universal truth of logic. If something is equal, it just can't be not equal. Once you understand that simple relationship in one system, you've pretty much got the core concept for all of them.
And we're not just talking about comparing whole numbers here. These comparisons can get incredibly precise. In a system like Siemens, for example, comparators can work with decimal numbers. Programmers call them floating point numbers. This lets them tell the difference between 1.5 and 1.51, a level of precision that is absolutely critical for things like temperature, pressure, and flow.
All right, let's keep building on this. To make a decision, a PLC needs data, right? But it also needs a way to get that data from one place to another, and to do some basic math on it. And this is where instructions like move and add come into the picture. The flow is actually super straightforward. First, a value gets captured, maybe from a sensor. Then, a move instruction copies that value, and finally, it gets placed in a new spot, a new destination, ready to be used somewhere else in the program.
Seriously, you gotta think of these instructions as the hands and the calculator inside the machine. They are the absolute workhorses, constantly moving numbers around, adding them up, and getting them ready so that those comparators can make intelligent decisions and keep the whole system running smoothly.
But hold on. With all this data being captured and moved and calculated, where does it all live? And how does the PLC keep everything organized so it doesn't get, well, totally lost?
Well, the answer is tags. And a tag is really just a friendly, human-readable name for a location in the PLC's memory. This whole idea is central to modern platforms like Rockwell Studio 5000. Instead of trying to remember some cryptic address like N70, you can just call it motor_speed. So much easier, right?
And of course, there are different types of tags for different jobs. An alias tag. Think of that like a nickname for a physical wire that's connected to the PLC, like a real-world start button. A base tag, on the other hand, that's for internal data. You know, the results of our add instructions or the current value of a timer. Okay, we've seen the pieces, sensing a moment, making a decision, moving data around. Now, let's connect all these building blocks and see the bigger picture, the universal toolkit in action.
So when you boil it all down, it all comes back to this one fundamental pattern: sense, move, decide. A sensor's value is captured, that's sensing. Then it's copied with a move instruction, that's moving. And finally, it's used in a comparison, and that's deciding. Sense, move, decide. That's the core loop.
So whether you're working in a tag-based Rockwell environment, where you might write a line of logic that says something like, if the tag motor_speed is greater than 1500, then turn on the alarm.
Or maybe you jump over to a Siemens environment, where you're using a direct memory address like MW0 instead of a tag name.
Or even in a Mitsubishi PLC, which uses its own syntax, the underlying logic is identical. You sense a value, you compare it to a set point, and then you act on the result. This is the universal language of automation.
And that right there, that is the crucial point. It's the single most important takeaway from all of this. The names, the colors, the software interfaces, all that stuff will change from one brand to another. But if you master these core concepts of sensing, comparing, and moving data, you can adapt to any platform, anywhere in the world. Thanks for joining this explainer. You now have the building blocks of this universal language. So the only real question left is, what problem are you going to solve first?
Like, share, and subscribe for appreciation and such more content.